Okay, so let's continue with the discussion. So let's go to area for polar coordinates. Now, since we know already how to graph your polar equations, that's what we did last meeting. So since we know how to graph now, we're now ready to solve the area given the polar equations. So in polar equations, the formula for solving the area bounded by these equations is this one. So area equals 1/2 r squared d theta from alpha to beta. So as you can see in the drawing, this looks like a sector, diba? So if you don't know what a sector is, so let's say you're given a circle, then that portion there, that looks like a slice of pizza, that is your sector, diba? Given a certain angle. Then if you're going to find for this area, so the formula is 1/2 r squared theta. Now, if you're going to compare the two formulas, so the formula for the polar coordinates is more likely the same as the area of your sector. So meaning it's being derived from that concept or area of a sector. So they are similar in format. Now, since the angular displacement in your polar coordinates is changing, so that's why we have d theta instead of theta. So in the case for the sector, theta is fixed because again it is already given in the problem. But in our case is we don't know yet what our theta is. So that's why it's changing, and that's why it's d theta. And then we apply a limit of integration from alpha to beta. That is the angular displacement of your polar equation. So from alpha to beta, and notice that alpha is on the bottom side, then beta is on the upper side of the graph, because once we try to measure the angular displacement, we're going to measure it counterclockwise. So that's our angular displacement. So for example, this is your x and y plane. So we're going to measure our angle counterclockwise. So take note also that your alpha should always be lesser than your beta. All right, so so let's proceed with the next slide. So let's try to immediately go to an example. So determine the area of the inner loop of r equals 2 plus 4 cosine theta. So we need to graph first 2 plus 4 cosine theta. So again, I'm going to show you solutions that will give you a perfect mark or a full credit score for the problems. So again, I don't want solutions to magically appear in your paper. So for example, you have the graph, but you don't have any evidences showing on how you have made the graph. So every part of your solution should have a basis or evidence that ano siya gikan ng inyong solution. So every solution should have a basis, or every part of your solution, so let's say your graph, should be backed up by a certain solution. Okay, so at this point, so since we are now allowed to use our calculator, so we can use mode 7, or I don't know what calculator that you are using, but in my case it's mode 7, that is mode table. And then you're going to plug in value of your formula. So this will be 2 plus 4 cosine alpha x. So next is if you're going to plug in the equation, so next step is going to ask for the starting value. So starting value is 0, then equal sign, and the value is 2 pi cosine, and then lastly is your step value. That will be the interval starting from 0 towards 2 pi. So that will be the interval. So our interval is 30 degrees or pi over 6, and then equal sign. Okay, so after plugging in the different parameters or conditions for your table mode, so next is upon pressing equal sign, so you will have the table which is on the left side, that will be the x parameter, and the right side will be f of x. So again, our x variable is the angle, the f of x variable is the r value. Okay, so you may write first the different angular displacement with 30 degrees increment, so 0, pi over 6, then pi over 2, 2 pi over 3, then you're going to write the different values. So again, don't forget that your mode is in radian mode. So what I'm talking about is, for example, this is your screen in your calculator. So the button, I mean the letter in the upper portion should be R. And I think that is shift setup. So in my case, it's shift setup and then rad. That's number 4 for my case. Because if you're going to plug in these data and then your calculator is in degrees mode, so the values that will come up is different. So starting with 0, you have 6. The next is 5.4641. Then 4. And then 2, 0. Then we have negative 1.464. Then negative 2, negative 1.464, 0, then 2, 4, 5.4641, and then going back to 6. So that will be your values for your table. So if you are presenting this in the exam later on, so of course this will be a valid solution for your graph by you're using. So again, since we are allowed to use the calculator, so just declare what you have done in the calculator lang. Then also present the different solutions. So starting with the 6, so let's just try to extend this one because the graph is only up until 4. So let's say this one is 6, Then let's say this one is 5, 4, 2, 0. And then at 5 pi over 6, so notice that this is 5 pi over 6. So we have negative 4.464. So again, this will be our positive 1.464. Then again, since it's negative, so we're going to put it on the other side of its line of action. So this will be 1.464. Then negative 2 of 4 pi. So positive 2 is at this location. So going to the opposite side because it's negative. So this is the point for pi. Then 5 and then 7 pi over 6. That's the same as 5 pi over 6. It's negative 1.464. So negative 1.464. So let's say at this point. So going to its opposite side because it's negative. Then going back to 0 for 4 pi over 3. And then next is 2. And then 4. And then 5 point something. Then going back to 6. So I just circled the yes. Drawing. Sige. Oh, ito. Sakto day. Sige. So thank you for that one. So this is the line of kanindi siya. Okay, so this is so I think the points are all correct now. So if you're going to draw again, you have to start from 0 and then going towards 2 pi. So again in counterclockwise direction. So here is, yeah. So just try to make your drawings perfect lang kay. In my case, I'm having a difficult time making it smooth in my graphing tablet. So again, this is the equation being governed by r equals 2 plus 4 cosine theta. So you're now done with the graph. So if you're able to graph your equations but you don't have any answers, so I'm going to give half credit for your solution because I think the graphing aspect is already difficult. So I think you made it halfway, so that's why I'm giving you half credit for this one. So determine the area of the inner loop. So inner loop is, since again the equation has two areas, so this one will be the inner loop. So this is the area that we're going to look for. Alright, so that's for the graphing aspect. So we can now proceed with the solution part. So this is the drawing coming from Desmos. So let's try to use this one. So again, this is the area. So the formula is area equals 1/2 and then r squared d theta from alpha to beta. So for r is we don't have any problem for r because we're only presented with one equation. So automatically our r will be 2 plus 4 cosine theta. Now our problem here is how we're going to determine alpha and then beta. So again, the as per theory for the formula, so let's say this is your graph here, then this is the polar equation, r equals something. So alpha is the starting point of the curve. This one is alpha, the angular displacement alpha. Then this one will be beta, the angular displacement going to the last part of the graph, meaning that will be the angle bounded by the area. So in our case, so the area is bounded by 0, then this portion here, what we have solved earlier. So if we try to go back to the previous slide, so let's utilize the previous slide first. So if we're going to observe the previous slide, so our inner loop, our inner loop started at 0, diba? So the inner loop started at 0, so meaning that will be at 2 pi over 3. And then it ended at 0 again. So from 2 pi over 3, it's 0, and then 5 pi over 6, it's this point, then negative 2, and then you have negative 1.464, then going back to 0 again. So this is the angular displacement that is covered up by the inner loop. So from this point, going up until 4 pi over 3. So that's the only portion wherein the inner loop was created on these angles and values. So obviously, so since we started from 0, then ended at 0, so it's safe to say that this will be our alpha angle, 2 pi over 3, because that's where the inner loop started. And then ending at 0 again, meaning in closing the inner loop, that will be 4 pi over 3, and this will be our beta. So the condition is also correct because as we can see in our declaration, alpha is lesser than beta. So did you get my point here? Or are you confused on what I'm saying on for alpha and beta? Okay, so again, you have to observe where the inner loop started because the problem is asking for the area of the inner loop. So again, you just have to understand the concept of sector because for sectors, you're only bounded by for the entire circle, and then let's say you're going to solve for a sector. So you only need to solve a certain portion of that circle, diba? Not the entire area of the given circle. So only a portion, just a sector of it. So that's the same concept as your polar equations. So only a portion will be solved in your equations. So alpha is the starting point of the loop. So let's say in the sector portion, this is your starting area. Then going towards the last area or the last boundary, which is this portion here. Okay, so if it's difficult for you to understand, so you may write also a somewhat sector. So you may write this one also. So a sector-like figure. So now since we know that our equation is bounded by 5 pi over 6 and then 7 pi over 6. So we're now ready to solve our equation. So we have from 7 pi over 6, it's gone there. It's bali siya. So it's starting from 2/3 pi there. So the 0 part is 2/3 pi, and then the other 0 is 4/3 pi. So starting with 2 pi over 3, the next part is 4 pi over 3. Then you have 1/2, then 2 plus 4 cosine theta squared d theta. So of course, if you have provided this equation, so you may directly apply it in your calculator, because that's the point here, is for you to establish the equation, not anymore about the techniques of integration. So in my case, I'm going to help my calculator a bit para dili kayo siya ma-confuse. But again, your calculator can solve this equation, but it will take siguro a bit of time lang siguro. So what I'm going to do here is I'm going to help my calculator. So I'm going to take 1/2 outside the equation. Then 2 pi over 3, 4 pi over 3. So again, take note that the default variable for your calculator is x. So this will be 2. So in my case, I'm going to enclose my equation twice. So 2 plus 4 cosine theta squared, and then enclose again with another parenthesis. Sorry, instead of theta, it will be x, this point. And then dx. And then, so this one is for the calculator. So area will be the area of your inner loop. So, sorry. So the area is 2.17. So you can write square units because we're solving the area. All right, so do you have questions? Okay, so I think that's the important part. So you have to provide, again, solutions for the graph. And then for your area is, again, only asked up until this point that you are providing the correct equation. So if your equation is incorrect, but your answer is correct, so I will not give credit to it also, because again, you have the wrong equation, but you got the correct answer, diba? So I think it doesn't make sense if you have that case. And I check your paper, so wrong equation, but you got the correct answer, so marag kuan siya, diba? So doesn't seem like you are getting the correct answer. So this is the solution coming from the book or from the resource. So don't mind the process. So then only write up until this point, then use your calculator to get the answer. Sige. Oh, pwede na dili. So just write the solution, I mean the equation, then you can use your calculator, then go to the answer na yan. Okay, sige. Okay, so let's proceed with an advanced version for your polar areas. So this time it's bounded by two curves. So the concept is the same as you can see in the formula. So you're just going to subtract the outer from the inner portion. So if we're going to discuss this in terms of polygons, so for example, you're going to have this sector, then you're going to have another smaller sector within that bigger sector. And then the problem is asking only for this area. So for you to be able to solve this one is, of course, we're going to get the bigger sector first, the area of the bigger sector. And then minus the area of the smaller sector. So notice that if we're going to do that, the resulting answer will be this portion only, the shaded region on the left side, or the portion above the bounded curves. So again, that's the same concept, because I think we're going to write the formula 1/2, let's say r outer squared theta, and then this will be the inner radius squared theta. Then if we're going to combine the equations, is you're going to have 1/2 theta r outer squared r inner squared. That will be the area if according to the area of the sector, so coming from area of polygons. Now again, since our theta is changing, so we need to shift it into d theta, so that's why it's d theta. And then that's why we have also the limits of integration as the angles. So I think that's the same concept. So let's try to appreciate the process. So let's start with graphing first the r equals 2, because if you're going to observe, so you have to determine the area that lies inside r equals 3 plus 2 sine theta, and then outside r equals 2. So we don't know yet what this graph looks like. We don't know yet what the area inside of r equals 3 plus 2 sine theta and outside r equals 2 looks like. So observing the two equations, so r equals 2 is simple compared to r equals 3 plus 2 sine theta. So if we're going to start with r equals 2, so that will be r equals to all throughout the angular displacement. So 2 here, 2, so 2. All throughout it's 2. So starting from 0 and then counterclockwise. So we can say that your r equals 2 is a circle. Okay, so next is r equals 3 plus 2 sine theta. So since this one is already difficult, so we can now use our mode table. So starting with the value, then ending with the value, then the necessary step or increments going towards the end value. So 0, then 2 pi equal sign, then pi over 6 equal sign. So you're going to have x and then f of x on the right side. So 0, pi over 6, pi over 3, pi over 2, 2 pi over 3, 5 pi over 6, pi, 7 pi over 6, and then 2 pi. So starting with 0, this will be 3, and then 4, 4.732, so these will be the values for your points for r equals 3 plus 2 sine theta. So starting with off is we have 3, and then 4, 4.7, let's say 5 at this portion here, so because we're limited with the graph, then 4.7, then 4, then 3, so 2. So notice it's crossing now the circle, 1.26 or 1.3. So let's say this portion here, and then 1, then 1.3 again, and going back to 2, then lastly is closing back to 3. Okay, so that will be your graph. So again, the red graph is r equals 3 plus 2 sine theta. Then the blue graph is the circle. So inside r equals 3 plus 2 sine theta, but outside r equals 2. So the area that is talking about is this region. So it's the inner part for the red graph, but the outer part of the blue graph. So this will be the area of interest. Okay, so that will be the area of interest for the graph. Okay, so before we solve the formula, so let's try to identify first the alpha and the beta. So since this one is the shaded portion, so notice that the starting value, so again we're going to measure counterclockwise. So need to measure from this point going towards this portion here. All right, so also take note that whenever you're going to apply the formula, so let's say these are the points here. So if you're going to draw tiny sectors all throughout your equations, so let's say I'm going to create a sector here. So notice that the outer part is the red part, and the inner part is the blue part. So it should be consistent all throughout the graph. So let's say I'm going to put my sector here, representative sector. So the outer part is the red graph, the inner part is still the blue graph. So even if I place it on the left side, so the outer portion is still the red graph, the inner portion is still the blue graph. So it's safe to say that I can use the formula. So I think that's the same case as what I have discussed for your rectangular areas. So the upper strip must always be touching the same equation, and then the bottom strip will always be touching the same equation wherever I put my strip, diba? So if I put my vertical strip at the very left portion, the upper and the lower equations will still be the same compared to the other locations that I'm going to place my vertical strip. So same concept for this one. Wherever I'm going to place my sector, the outer portion will be the red graph, and then the inner portion will be the blue graph. Alright, so for this portion is, we can say that the graph started at this point, at this angle here. Diba? Then rotating counterclockwise, and then ending at this portion here. The points of intersection between the two curves. Diba? Because this is the area here. So ending at 7 pi over 6. So starting at 11 pi over 6, ending at 7 pi over 6. So if we're going to enclose the values for this one in the table, so this will be the other value. So of course it also verifies that this is the point of intersection, because you have 2 for the circle, then 2 for the points as well for these angles for the other equation. Okay, so since we're rotating counterclockwise, so we have to start with 11 pi over 6. That will be our alpha, and this one, I mean this one will be our beta. So again, we need to follow the condition that alpha should always be lesser than beta. So notice that alpha here is bigger compared to your beta. So 11 pi is, so again, if we try to compare, so it's greater than, di ba? So we have not yet fully met the condition that alpha should be lesser than beta. So to do this is we're going to get the negative counterpart of 11 pi over 6, which is negative pi over 6. Negative counterpart, negative angle counterpart. Okay, if this is 11 pi over 6, that is rotated counterclockwise. So if you rotate this one in a clockwise motion, so this is negative pi over 6. That's the negative counterpart of that angle. So instead of 11 pi over 6, so we're going to use negative pi over 6 is lesser than 7 pi over 6. So we now have met the condition that alpha should be lesser than your beta. All right. So do you have concerns or questions regarding this one? Okay, sige. So this is the graph. So again, what we're going to be solving is in this region here. So again, 11 pi over 6, then 7 pi over 6 is the boundary. So if you don't want the tabular method, the manual method, you can always equate the two equations in solving the points of intersection. So r equals 3 plus 2 sine theta. Then the other equation is r equals 2. So if we're going to plug in r to the second equation, so we're going to have 3 plus 2 sine theta equals 2. Then isolating your sine function to get the point of intersection. So you have 2 minus 3, then you have 2 sine theta, negative 1, then sine theta equals negative 1/2. Then getting the arc sine, so the value is negative pi over 6. So there's a topic in your in your trigo wherein if you solve that particular angle, there's a counterpart angle for that given angle. So if you try to look it up online, so the counterpart for this one is 7 pi over 6. So I forgot the title of that certain topic. Basta your angles have a counterpart or a pair wherein the value will still give you, I mean, if you plug in that particular counterpart, it will still give you the same answer. Okay, so this is the how we get the points of intersection if we're going to um, use the method of equating your given equations. But I think this one is complicated, especially when depending on what area you're going to solve. So area is again from alpha to beta. So again, this is our negative counterpart for this one is negative pi over 6. So again, we measure counterclockwise, going towards the opposite side, 7 pi over 6. So negative pi over 6, and then 7 pi over 6. Then we have 1 half. So starting with the outer r first, that's the red graph. That will be 3 plus 2 sine theta squared. And then minus the blue graph, which is 2 squared. And then d theta. So again, from here you can already use your calculator. But in my case, I'm going to help my calculator a bit so that mas dali mo hatag answer. So what I plug in my calculator is this portion. So I take 1 half outside and then parenthesis for the outer equation. So again, it will be in terms of x because you're using your calculator at this point, squared. So instead of 2, I'm going to place 4 because 2 squared can be simplified directly or can be simplified mentally. So that's how I want my equations to do. Pila? So 24.19. So square units. Okay, so questions so far? Alright, so no questions. So let's proceed with, so this is the solution, eh? So this is what I meant earlier, that whenever you get a certain angle for your trigo function, there's a pair of angles for it. Baso ka ni siya. So 24.19. So again, you may start by just providing the solution, and then this one is neglected because again, you're allowed to use your calculator. Then you can proceed with the final answer. Alright, so I think we can now go to the next example. So still on the same example, but this time is we're going to determine the area outside r equals 3 plus 2 sine theta, but inside r equals 2. So inside this r equals 2, the blue graph, but outside the red one, so this will be the graph of interest. So notice that we're going to have the same limits. So from 7 pi over 6 going towards 11 pi over 6. So again, if I try to draw different sectors, so let's say I'm going to draw a sector here. So the outer portion is still the blue one, the inner portion is the red one. So if we're going to place it here, so end to end lang para dali lang mahuman. So blue, then red inside. So that's the same portion. So again, we measure counterclockwise. So our alpha now is 7 pi over 6. Our beta now is 11 pi over 6. So I didn't show the graphing portion now because since we are dealing with the same problem. So alpha is equal to, again, area is equal to, so from alpha to beta, 1/2 r outer squared minus r inner squared d theta. So alpha is 7 pi over 6, 11 pi over 6. So again, alpha is lesser than your angle beta. So our outer equation now is the blue graph. So this will be 2 squared minus the inner graph, which is the red graph. That will be 3 plus 2 sine theta squared, then d theta. So again, try helping your calculator a bit para magawas ang answer na yun. So we have 4, then minus 3 plus 2 sine alpha x squared, and then dx. So I try to enclose the terms with parentheses as much as possible so that there will be no confusion on the operation for your equations. So for example, you have negative something, then again, if you are lacking parentheses, the calculator might get confused when solving the equation that you have provided. So that's why I input many parentheses in my calculator to make sure that those terms are only exclusive to that particular numbers. Hindi na siya masagulaglain na one. Okay, so area is 2 point. So 2.2. So square units. So things are now easier in the second half because you're now able to use the calculator. Alright, so this is the solution. So again, you can exclude this part here. Alright, so for the last problem is you're going to determine inside both the red graph and the blue graph. So inside the red graph, inside the blue graph. So this is the area here. Okay, so if you notice, that will be the same boundary. But if you try to check if the sectors are consistent, so let's say I'm going to place my sector here. So notice that it's only touching the red graph, diba? If I draw it on this portion, I'm touching only the blue graph. So if I make my sector here, I'm only touching the blue graph. So the lower part is touching the red graph. Especially if I try to place my sector here, it's both touching the red and the blue graph. And again, it should be that our sectors should be touching two equations, one outer and then one inner. So for this case, is we cannot use the formula, so we need to think outside the box. So in order to do this problem, so we're going to again think outside the box, and I think we're going to use some basic knowledge from our solid geometry. So as what I have discussed earlier, so we may find the area of the circle first, and then minus it with the area that we have solved from number 3. Diba? So we can do this in this option also. Then what is left is the upper portion of your graph. So this is one way of solving this problem. The second way is for you to solve the entire graph for the red portion, so meaning the area of the limacon. And then minus the area that we have solved from number 1. So if you forgot what the area for number 2 is, example number 2, so it's the same figure but magana siya, diba? More siya crescent. And then this will give you the same area. So that's how you are going to solve this problem. So we solve this in this manner because again, when we check our sectors, so it's only touching one graph and it's also not consistent because one is so in some portions it's touching the red graph, in some portions it's touching the blue graph, in one portion is touching the red and the blue graph simultaneously. So that's why we think outside the box and we came up with another way to solve the certain area that the problem is asking for. So I'm gonna leave this solving to you, but if you want to verify your answers on your own, so this is the solution. And that is the answer for both areas or both methods. So just try to solve number 4 on your own. So you may start from scratch, like you're going to create the graph first. Okay, para at least yung maagian tanan. So if you're going to solve number 4 on your own, so you'll be solving back again example number 2 and example number 3 before you can solve example number 4. Alright, so if you don't have any more questions, so I think that will be it for today. And your problem set will be up in a few minutes once we ended this discussion. Okay, so thank you all very much for listening today, and hope to see you all again next week, next meeting.